Hi, hello everyone. So very few people have joined today. I don't know why. Maybe people are losing interest. Don't know. So today the plan was that we'll discuss about week six. I hope you have done well in the week six assignment. I don't know what is the case for all of you. Uh, because I think some supplementary was given to all of you so that you can solve the problems. So I hope that was useful for all of you. Actually, we discussed, sir and we and the other teachers. So that was the plan because since we could not manage to arrange any other session before the deadline, so we thought of let's make a PPT and that will be beneficial for you. I
So
hope
today
that.
you are covering those six
Yeah,
week
yeah, that
assignment which we
that
found it.
yeah, yeah.
Okay. Thank you
Assignment
so much.
six. Okay.
Yeah,
So
yeah.
that will be those will be solved today only, and try to give some hints of week seven so that I think week seven deadline is also nearing. So okay. So people will
Yeah.
join anyway. So let me start then. I think. So how was it actually? Someone can say how. I mean, the answer is there. So was it okay or not? All the problems are numerical. Some are theoretical problems are there also. So did you do well there, or the numerical was the problem, or what was the problem? Because the
Numerical only was the problem, and other things were also like very confusing when it comes to theoretical.
okay. I think some doubts are there. I think some in the discussion cell forum, or I think they have mailed to sir, the course instructor. So he was saying that people are confusing. So yeah. So anyway, we'll discuss those things because you see the problem that are given pretty formula based. No very tricky things were there. So here no logic and all those things are there. But yeah, maybe you are confused with the formulas, what to put and what not. So we will discuss that. So I will not wait anymore. We'll start. Okay. So yeah. So today is I think tutorial six, week six. Okay. So first case is the mention. This
You're going to
chapter is
share this presentation also with us by any chance?
sorry.
You will share this presentation also with
Yeah,
us?
yeah. This will be shared in that Excel sheet only.
Okay, fine, fine.
Yeah, yeah. Every week's presentation and the PPT both are shared. No problem. Okay, so all this chapter is about as you have seen is about scientific measurements, how to measure, how to calculate this mean value, how to calculate error between a large number of sample or a small number of samples. So this chapter is all about those things. Okay, so basic thing is that we'll start with this mean. So you can see, so how to calculate mean? Mean is simply the average value. If you simply understand, this is just the average value of a given sample set. So if you look at here, you can see mean equals to sum of all data points divided by number of data points. Okay. So suppose there are x1, x2, n number of data sets are there. So mean will be x bar with summation of x by total number of samples, that is n. So yeah, so this is the equation. I value can be between n to 1 to n, and so this is the summation. So this is pretty easy one. So there is an example of that. So this is a sample set or data set 10, 20, 36, 12, 35, 40, 36, 30, 36, 40. So there's a number of data sets. So total 10 is there. So total summation is 295, and if you divide by 10, so this will be the case of mean 29.5. So this is the preliminary step of calculating anything in this scientific regime, like of a given data point. So these, why do we do these things? Because let's say you are doing experiments in any time, so you have to anyway repeat the experiment, right, to get it to confirm that okay, this is happening actually. So let's say there are some intensity value, or what should I say, some resistance value, some kind, this kind of values you have to measure. So you are measuring for a particular system. Let's say there are different values might come, and different values should come actually. It cannot happen that every time you are getting every the similar data. If you are getting, that is very good, but in the scientific regime it is considered to be that there are some kind of manipulations, or some kind of things are involved in that case. Because what the case is that every time, so I'm saying in this, in a very broader view, not very specific cases. In specific cases this might happen, but the case is that whenever you are doing the repeating the a similar experiment, might be some manual or some kind of environmental, some kind of change should occur there. So in that case, the data will come, although the change might be very minute, but it should change. So once it changes, so you have, that's why if you repeat at least 3 times to 4 times, 5 times, so you will get some data, and then from that you will do the average, that is the mean value. So you will put that this was the resultant. Okay, and based upon those data samples of data, you have to calculate this error and standard deviation, all these things. Okay, so this was the first part, that mean value. So mean value is nothing but the average. Okay, so now I'm coming to the next thing is, you understand, there is the standard deviation. So this is the simple straightforward equation for that. So standard deviation equals to upon root summation of xi minus x bar whole square by n minus 1. So where ni is the value of ith point, so at point at I, and x bar is the mean value, and n is the total number of data sets. So if you see in the standard books for this research methodology or analytical chemistry, or this kind of books where these methods are very elaborately described, and how these values are coming, the derivation, actual derivation of these equations, so those are also described there. So we are not, I am will not describe those things here. Anyway, those that you have read, or if you are interested, you can go through any standard books, you can find there. So so what we have to do, what are the steps to find the standard deviation? So you can see, find, first part is find the mean. Okay, So you have that we know now. Next, for each data point we have to find the square of its distance to the mean, like the difference value. Yeah. So this value, basically this one, this we have to calculate. Then you have to sum the total value. So this is the summation. So square of this difference, and then summation of these total squares, and then divide by n minus 1, and then take the square root. So this is the overall thing. Okay. If you put this data simply to a given data set, you will get the answer of standard deviation. So the task is a bit tedious, because what we have to do, you have to calculate each, for each data point you have to calculate this value. So if there are, let's say, five data set, or there will be one mean, so there will be five these points, and you have to calculate this value for each point, and then square and sum of them, divide, and then you will get the answer. Okay. So this is, I hope this is easy. This is not that difficult, because I don't think you will ever you will anyway use any kind of calculator for using these square values and summation. So then it becomes easier. So okay, so this is the standard deviation, right? So here one thing is that one value is hidden in this case, that is this variance. So variance is this, basically this square value. Okay, variance is this summation of this value. Basically, the square of standard deviation is called variance, right? So this is also an important point. Now we will see some examples, maybe. So first example, there are given data sets. So you can calculate if you want. So that will be helpful for you. You just do this, because this for this, or these are done here. But you can, if you want, you can calculate on your own. So that will be helpful. Okay. So 5 point data set are given, like 2, 1, 2, 3, 2, 4, like these are. And so for that you have to calculate all these things, like the mean and the standard deviation. So first is the mean. So total, where total is 12, and there are 5 data points, so it will be 12, 2.4. Okay. Now, to calculate the second part was to calculate this difference from the mean. So 2 minus 2.4 minus. So there is no point, if even if some point will obviously become minus, because the average or the mean value will be in for will be
This calculate the difference from the mean, Chandranath. Sorry to interrupt.
sorry.
The second step which you have given, the subtract the mean from each
Uh-huh.
value. So here we are
Yes.
trying to find out what standard error, what we are trying to find out here, or error bar. What is that?
No, we'll calculate the standard deviation. Yes, simply.
Standard. Okay, for the
Standard
standard
deviation.
deviation only.
Yes, yes.
Okay.
So part one by
Okay,
one
thank you.
we'll come to those things. Yeah. So
Okay,
here,
thank you.
yeah, yeah. So what I was saying, that some values will anyway come negative, so there is no problem, because anyway we'll make a square of that. Okay. So this is the summation of square. So that's why the negative will not matter, when once it's square it will be positive. Okay. So now you can see the values are given. Uh, yeah. So these are the subtracted value. Now these are square. You can see. So now this is the summation. So summation. So since this is 5 data set points, so this will be not a problematic in that sense, because you can do it manually as well. But if you have to do for a larger data set, you have to take the help of calculator anyway. Now, so as I was saying, this is the variance. Okay, now before doing the square root, the value we have gotten 5.2 was the summation by 5. 5 was the, so this will be 1.04. Now this is square root of that. So these are the values. Now another data set we can see. So you can see this data set is pretty large, and these values are also big. So So if you see there, how many are there? There are total 15 data sets are there. So 85, 86, 100, 76, 81. You can see the values, right? So then you have to do the calculation from there. So from there, whatever we are getting, the variance value is 75.6, and then the standard deviation value is 8.7. So if you want, you can calculate. So anyway, we are coming to other problems. So there where you have to do on your own. So this is the way. This is the one. This is very simple things. Okay, very formula based things. Once you get the formula, you will easily do it. Right. Now we are coming to standard error. So what does standard error mean? The standard error is one of the mathematical tools used to statistics to estimate the variability. Okay, variability means how much value can vary. So what is the range of this variation? Okay, that's what we are calculating actually. Of the mean is that, and how much this mean can actually vary. What is the range to positive to negative side? It is abbreviated as AC. The standard error of a statistic or an estimate of a parameter is the standard deviation of its sampling distribution. We can define it as an estimate of that standard deviation. Okay. So what is the formula? Formula is S by under root M. S is we have calculated earlier, that is the standard deviation. So standard deviation by under root number of sample size. So this is the standard error formula. So if we sum what we are getting is, first we have read mean, then we have gotten standard deviation. Now we have calculated standard error. So let's see one two examples. So let's say this is a data set of 5, 5, 10, 12, 15, 20. So you have to calculate the standard deviation value. First the mean value. So this is the mean value. If you see 10.5, then we are calculating standard deviation. Standard deviation, and then we are calculating. So this is the standard deviation value 5.35, and then we are calculating the standard error. So s by under root n. So 5.35 by under root n, under root 5, so the value comes to 2.39. So how up to how much decimal we have to provide the answer, that is already mentioned in the any given question. So anyhow, till now, for the provided questions, it is usually asked for two decimal, but it might ask for the higher one as well. Okay, so this is the straightforward formula for calculating the standard error, right? Now, so one question, so one problem is that, so this is given now, 12, 25, 41, 64, 88, and 112. So these are the data set of 6 points. Now you have to calculate the same things basically. So mean, standard deviation, and standard error. So I think all of you just take a pen and paper and try to solve it. I'll wait for some time, then we'll see the answers. Answers are given here, so you try to solve it. Okay. So formulas are given already. You have to just put there and calculate. It will take some time, but I hope you will do. So let's say take a time for 3 4 minutes. So the data set you can see from here. Whoever joined just now, so we are solving the problem. So we were discussing about the formulas for mean, standard deviation, and standard error. So a problem has been given of 6 sample sets. So now you try to solve the problem and try to calculate these data. And you only unmuted want to say something, otherwise you can mute yourself. I cannot see actually who is this. Everybody, please try. Okay, this will help you only.
Hmm.
So, what whoever is done, if anybody is done, you can wait. Let other people finish, and we will see.
12 plus 25 కదా 37 plus 41 38 78 78 864 82 144
So please, please
142
mute yourself. You are calculating, I think.
142
What is it?
442
Abdul Hafiz, please mute yourself. You want to say something? Giving the answer, or I think yeah. Okay. We'll take the answer of also.
I got 15.64.
Yeah, wait. So I think we are waiting way too long. So everybody's done. Anyone still trying? We can then wait. Otherwise, we'll go forward.
Still
Anyone
trying.
want? Sorry, trying?
Still trying.
Okay, okay, okay. Let me know as soon as it's finished.
I'm getting 6.5.
Yeah, yeah. Just hold on. We'll take everybody's answer. Yeah, whoever is done, you may give your answer in the comment section. Oh, you can wait because people are trying still. So
So is calculator allowed for the exams?
I think output is allowed, right? Because
Okay.
this is not possible
Yeah.
to do within this
Yeah. It'll
limited
be
time.
difficult for square root.
Yeah, yeah. Huh. So,
Hello, good evening, sir.
yeah, yeah.
Am I audible, sir?
Yes, yes. Who is this?
Sir, I am Minal Gutte from
Okay,
YCC.
okay. Mm-hmm.
Sir, actually, in last assignment, in assignment 6, I have query about that, sir.
Yeah, yeah, we will discuss about the assignment 6 problem. So first we are trying to solve few other problems related to that. So like this mean, standard deviation, all this. So a problem is given now, if you can see the screen. So people are trying to solve these problems. Okay, this mean trying to calculate these values, mean, standard deviation, and standard errors. The formulas are given.
Okay,
We are
sir.
just going through that. So if you want, you can try now. We can wait, let's say, for another 5 minutes. Then we will anyway discuss the problem, discuss the answer, see the answer.
Okay,
Okay.
okay.
Yeah.
Sir, is it 15.64?
Uh, Three values are there. So
Standard
mean,
error.
standard deviation. Yeah, we will see. We will see. You hold on. People are trying. So how did you do that first? Try to use the formula and try to do that
Sir, my
only.
answer
Not
is 15.64. Standard error.
okay. Other two values you have to say also. But
Okay,
hold
okay,
on.
okay.
Hold on.
Okay.
Yeah. So I think we can check it now. Okay. So let me check anybody found the second answer. Yeah. People are saying 57. Standard deviation 38.31. Standard error 15.64. Okay. All are okay. Sorry.
Your the PPT is not visible.
Yeah. 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 So let's see what is the answer. Yeah. So mean is correct. 57. Standard deviation is 38.31. And standard error 15 percent. So how many people have done it? Is it okay for all? Is it for anyone? Is
Sir,
it
standard.
mismatching? Yeah, this still.
Sir, can you explain the standard error value?
Okay, there's nothing to explanation actually. So you
Sir,
have to just.
please show the answer slide. Answer slide, please show.
Yeah. Coming. People joining actually. Yeah. Is it matching with you?
Yes.
Yes, sir.
Whatever I have seen, I think those
Mean
are matching.
value. Sir.
Yeah. So mean is okay. This is the problem.
Sir,
Mean for me, mean is matching, sir, but then standard deviation, the answer is different. I don't know where I made a mistake.
Yes, same here.
Yeah. So how is what is coming it? What is
34.9.
okay? So did you calculate by in calculator? Like the
Yes, sir.
okay. Uh, I don't know. It might be, but this was the answer that was given. I need to check then. I didn't do it by myself. So this was the answer given actually. So okay, I'll check.
That's
Sir,
Yeah.
correct.
excuse me. Sir, for
Sorry.
standard deviation, the formula which you have given, with the formula, see, I am not from maths background. That's why I am not clear
Me
about the
neither.
things. But the
Me neither.
step one, two, three, four, five is to be followed, and we'll get the answer, right?
Yeah. Absolutely.
Okay.
So anyway, so this is the very straightforward method. So you have to just follow. Okay, you will once you do. Let's. I mean, you can check. Or you might have done a mistake, or this answer might be wrong. I don't know. I'll check. But the simplest straightforward, you will just put the formula. You will do one by one because you see there are 6 points are there. So there will be six. That is six. One mean value, one six division six subtracted value, then square of that, addition summation of that, division of that, and then root over of that. So as simple as that. So and then standard error is whatever value you are getting divided by under root 6. So this is the same straightforward we are getting. Okay. Now, okay, I'll check that whatever what is the answer. It might differ, but I hope if you are putting the formula correctly, this should come this.
excuse me, sir. I
Yeah.
have one query. Sir, while writing standard error, there is a
Mhm.
need to mention 50.641, but after point 641, three-digit number is
So it depends.
necessary
Like
or to.
it depends.
Okay,
Like you can see in the questions, they always say that you provide the answer up to two decimal. So if it is given up to two decimal, they are asking, then you have to simply say 0.64. But if they ask for three decimal, then you have to provide. Okay, that I was
okay.
saying. Yeah.
Thank you, sir.
Yeah. So now I'll just quickly. This is you don't have to worry. I'll just quickly say what is central limit theory. You have read about that. This is not this theory.
Sir,
So just
sir, just I want to ask in
uh,
assignment number say, 6,
so
in question
we will discuss. We will discuss all the problems coming. Before that, I'm just
no, sir, because I have not get marks there because my answer is correct, and even though I not get marks there, the standard
uh,
error there is a 0.86, but you
mhm.
have mentioned there 0.82, but according to calculation it is 0.86.
Yes,
At
ma'am.
the end
Yes,
of the
exactly.
session, we
Yes,
will
ma'am.
take up this one.
Same, same.
But
Okay.
answer is
So
This is
0.86.
also happened with
So,
me, sir.
so you are saying
and we
that you
lose
have given correct
we lost our
answer,
marks,
but
sir. That's why.
I understand. But in that case, you can write that. You can write to that NPTEL. So because you see that this answers has been checked by their system only. We cannot do anything with that. Okay.
No
But
means
if you
in this
feel,
case, how we will connect to you? What
uh,
option is
if
there, sir? Actually, I
you
have
don't,
dropped one mail to sir
you
also.
you just drop one mail to the course instructor
I have
because
dropped, sir.
yeah, so
Before
he will
2 days, I
take
have
care of
dropped,
that. Uh-huh.
but there is no response from him.
Uh, it might that he will correct it in your case, but you can mail back again. But what I understand and what he said that because few queries were there regarding assignment 6. So this is I am talking about before the deadline. Okay. So that's why he called us and we discussed that what can be done. So that's why he prepared a PPT and that was shared with you, right? Now,
And
if you're
also,
saying
sir, in question number 2, in assignment number 6, error bar is there 0.0109, sir, because samples are given there.
uh
And according to your answer, the it is in the range of 0.0106, 0.0108. But actually it is
what I am
0.0109,
not
sir.
understanding according to which answer. So so this is just this is not a problem taken from assignment C. This is a random problem. So
Yes.
why are you confusing this answer with that? I'm not clear. So can you elaborate? What what is the case? This was the problem given here, but assignments as where values are different, right? So what you want to say?
Madam, this is
No,
a
sir.
different assignment what he is taking, and he will take all the assignments at the end. That is what he is telling. That time the question will come. That time you
Yeah.
can ask, madam.
So
Okay, but
this
this question is not given in any assignment. That's why I am
no,
telling,
no,
ma'am.
No, no,
The
it is
question,
not given. That is what he is trying to tell, that it
so
is
this
not
is
in
not
any
even the
assignment. It is
assignment.
a
This is
random
just a
question.
yeah. This is just a practice we are doing here. Okay, it's
yeah,
not a
this is just
problem
a
given.
practice.
Yeah,
But I have problem in that assignment, sir, because I lose my
No,
marks.
let's proceed with the class, and when the problem comes, all of us are waiting for the problems. Equally, we are
yeah,
waiting for the
yeah, yeah,
problems to be solved.
yeah, yeah.
Okay.
So, so this is central limit theorem. I think you have all understood what is the case. So, it is statistical theory states that when this is about sample size. Okay, so this will help you to which path you have to take for calculating all these variables depending upon the sample size. So, when the large sample size has a finite variance, the sample will be normally distributed. Normally distributed means the formula that we are considering till now, and the mean of the sample will be approximately equal to the mean of the whole populations. In other words, the central limit theorem states that for any population with mean and standard deviation, the distribution of the same mean for sample n has mean mu and standard deviation sigma by under root n. So these things you know. So this I have just included because it might be helpful while reading because uh, as a material. Okay. Now for sample mean, this will be the formulas for for sample mean. So z you can see. So I think I can these problems can be discussed a bit later. I have included those earlier maybe. Okay, before that, this is also another important. This is confidence intervals. Okay, so regarding this, also some problems came in the assignment. So confidence interval is what? A confidence interval is the mean of your estimate plus and minus the variation in the estimate. So this is the range of values you expect your estimate to fall between if you redo your test within a certain level of confidence. So confidence means how much percentage confident you are about the data that you are getting. Like let's say if you are 95% confident, it means there is 5% possibility that the value or the mean value that you are getting is sorry, the value that you are getting, there's a 5% possibility that being wrong. Okay, so this I mean theoretically it means that. So confidence in statistics is another way to describe probability. For example, if you construct a confidence level of 95%, you are confident that 95 out of 100 times the estimate will fall between the upper and lower value specified within this confidence level. Means the 5% chance is there, so that value will not come within that range. Your desired confidence level will be a 1 minus alpha or a value. So alpha value or a value comes from this different statistical tests. I think you have by now you know that in week 8. So different kind of test have been described, like T test and student T test and like I test. So multiple tests are there. So from that you can calculate, like Simply is this p value, if you consider. So this is one kind of a test, that is just student t test. So from there we get a p value. Okay. So for any if you once you provide any data for any kind of journal communication in any kind of scientific result, you have to provide these values for multiple data. Okay. Now once this p-value can be less than 0.005, in that case we put 3 star. Once it is less than 0.05, we put 2 star, and it is less than 0.01, we put 1 star. So 1 star means, so I mean, so in that way, the confidence level changes and the reliability of the data increases. Okay. So for this case, it is considered as 0.05. So 0.005 means 99.995% it is true, and rest is not consistent or confident. Okay. So for 0.05 means is 95% simply. So in any case, simply we consider it's 95%. 5% error we always consider if once any nothing is said. So this is a simple thing for confidence interval. So the formula for calculating this confidence interval is also important. You can see CI, that is the confidence interval, equals to X bar. So X bar is the population mean, plus minus. So this is the value Z star into sigma under by under root n. So Z star is the critical value of this Z distribution. So this we will also see how to calculate. Then sigma is the population standard deviation. You can see here, and n is the total number of sample size. Under root is the square root of that. So the confidence interval for the t distribution follows the same formula but replaces z star with t star. Like so, this will come. Okay, when to use this t value, right? So this is the simple formula of confidence level: x bar plus minus z star sigma under root by under root n. Now, what is this Z score? This Z value we have calculated, we have seen earlier. Case, what is that? A Z score can be defined as a measure of the number of standard deviation by which a score is below or above the mean of a distribution. So, whatever I am saying, this is the physical significance of these values. Yeah, so this is the Z score basically, or Z value. In other words, it is used to determine the distance of a score from the mean. Okay. If the Z score is positive, it indicates that the score is above the mean. If it is negative, its score below the mean. And however, Z score 0 denotes that the data points are same as the mean. Now, steps to calculate Z score: convert the confidence interval into decimals. Confidence interval you have to, and find the alpha value. Alpha equals to 1 minus confidence interval. You have calculated. So these are basically the back calculation for calculating Z once other values are given. Okay. Now, what does this signify? The Z score for 99 confidence interval. What does this mean? If you see, the Z score for 99% confidence interval implies that 99% of the observations lie between the standard deviation of 3 and minus 3. This is given as follows. So 99% points up to 2 decimal is 0.99. Alpha value equals to 1 minus this confidence interval is already given 0.99 by 2 equals to this. So area under this curve will come equals to this, and then this Z score value will be 2.57. Okay, so this is for simply for 99% value. So you can also remember for this 99% confidence value, this Z value will come as 2.57. This is the standard values, okay, for 99%. And same for this 95% case, this value comes as 1.96. So this will be helpful. You have, I mean, you can calculate, but if you remember for these two cases or few cases at least, you can see that will be helpful for solving the questions.
Sir, one doubt.
Yeah.
Sir, the value of Z score, the standard deviation for 99% confidence interval,
Mhm.
it implies that the observation lie between the standard deviation of 3 and minus 3 sigma. But what we have taught in the class in the lecture is for 99% confidence interval, the standard deviation values lies between minus 2.58 sigma to 2.58 sigma.
Yeah. Actually, there is a difference. So that I have seen. So what sir has
Because
taught?
the
Yeah,
Z
yeah.
score for
So
99%, 99.7% lie between minus 3 sigma to plus 3 sigma, but 99% for 99%, the accurate value of standard deviation lie between 2.58
yeah.
sigma to minus 2.
I
Yes,
understand
sir.
because so what is the case is that for a for this so there are two cases are there, as you know, when the sample size is less or very small, so in that case a different value comes, as you know now. So that is called a t value, right? So for this t value, uh, here the sample size has been taken as 25. Okay, so that's why once it is considered in the standard deviation, it is comes under minus 2.5 to plus 2.5. But in general case, I mean in other cases, what the available sources is taken as 30. So that's why it is plus 3 to minus 3. So you can then, as it is taught in the class, you just consider this to be as minus 2.5 to plus 2.5. Anyway, the number will come as 2.58 in that case, I think. And but this value will be anyway 1.96. I think that is the case, right? If you see or if you calculate from that value, this value will come. This there will be not much change in this z score value. Okay, because even if you take this radius, so there is not a problem. Anyone you want to take, you can consider, right? So for the Z score for 95 confidence level, this value now comes is as 1.96. So if we try to calculate one example, so this is the formula you can see for here. Now, one problem is given that a random sample of 30 apples was taken for a large populations. On measuring their diameter, the mean values of the sample was 91 millimeter with a standard deviation of 8 millimeter. Now, calculate the 85% confidence limits for the mean diameter of the whole population of apples. Now, so 30 apple is given. So since it is a sufficient number, so then it is normal formulas will be followed. So now, what is the case for 85% confidence? What will be the z value? We have to calculate the z. If you calculate putting the formula, it will come as 1.440. You can calculate if you wish now as well. But okay, then this mean value is given as 91. Ace is 8 standard deviation. So and the sample size is 30. So what will be the case? So substitute all these value x bar plus minus z star into s by under root n. So 91 plus minus 1.440 into 8 by upon root 30.
This
So
Z value,
yeah,
sir, this Z value which you have taken 1.440, from where it came?
it
I
is
couldn't get it.
calculated
Can
from
you
here only. So you see, I was saying. So
using the formula confidence interval? No, no.
yeah. So
Acha, acha.
alpha, so confidence inter. So
Hmm.
you see how it is getting calculated here. So yeah, so here the confidence level is 99%. So the limit they have taken is from 3 to minus 3. That is not a problem. So here, so now you see what you have to do. It means you have to subtract from 1 the confidence interval.
Hmm.
That's 1 minus 0.99
Okay.
by 2. So this is the value that is coming. So area is 1 minus 0.005. So then you have to, for calculating this z score for 99% confidence is coming as 2.57,
Sir,
right?
can't we
Yes.
calculate the Z score by the formula, the difference between the sample mean and root add of the population mean divided by the standard error?
Yeah, can you repeat?
Can't we use that formula for calculating Z score?
Yeah, you can use. There's no problem. You can use. You can use it.
But here the
Yes.
mean population, the sample
So,
population is given, but the mean population is not given in the question.
Sample
yeah,
mean is not given.
sam-
Sample mean is given 91
sample mean is
millimeters,
given.
but
Uh-huh.
the population mean is not given.
Yeah, population mean is not given. That is a case. So, so for whatever you are saying, for that you need the population mean, right?
Yes, sir. Yes, sir.
Yeah. So
So then that formula only should be used, the one which you told that
So
yeah, yeah,
this,
was
can I
what
just
we
interrupt if you
referred.
don't mind?
yeah, yeah. Please.
Yeah, so this 1.96 is 2 standard deviation and 2.573 standard deviation. That is, it is a constant. It is like pi value
Yeah, it is like
for
a
Z.
constant. So
Yeah,
that's what I
yeah,
was
yeah,
saying.
yeah.
Yeah.
Yeah, but here now what everybody is asking is what is the way you have derived this 1.440, because 85% confidence. We know what is 95 and 99. So for 85% confidence, like, how did you get this Z is equal to so much?
Because
So
these are true values, what I understand.
sorry.
Z confidence when we say 95%, 85%, 99%. So it is true values, right? Whenever it is given, we can consider
Uh,
that value, right?
yeah, 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 yeah. So this value, as I was saying, this from this formula only. I was saying, no, from this formula only you can calculate this Z value. So for this 99%, this area under the curve is coming as 0.995. So from that they are calculating this Z value. Let me check one second. Uh,
But this will be kind of a constant, no? Because this is
it will be
one-time
kind of a constant.
calculation.
Yeah, it is for any particular confidence level. It will be kind of a constant. Yeah, definitely.
Constant, yeah, yeah, that's what I'm saying. Okay, but the way it has to be calculated is this what you
Usually,
have
yeah,
showed us.
usually the values is asked only for this 99 and 95. That is the case. This is the
Yeah,
really usual case. I mean, questions are asked. But for some other cases,
85 is yeah, 85 is a different. That's a reason. In exam, will they provide this table, sir?
yeah, I think this table will be provided because otherwise it will be difficult,
Yeah,
right?
yeah.
Yeah. So in that case, you can see that these are the values. This is coming. This is 91 plus minus 2.1, right? So
Okay, so
yeah, so this table will be definitely provided as far as I remember, as I know, because I'll talk to sir then. Because for solving these problems, this table is required actually. So another
yes,
problem is, yeah. So okay. So another problem is there for 90% confidence limit. So the problem is a random sample of 10 scores obtained of students in a math test is you can see the number. So what will be the 90% confidence limits for the mean of a whole sample, right? So now the values you have to calculate basically. So values for this case. So values the average value it is calculated. Now standard deviation is calculated. Now then you will calculate this error as well. So for the 90% confidence, this Z value is coming to be 1.645 in the similar way. And simply now you have to put the formula and you will get the data as 8 plus 8 plus minus 2.3. So these are pretty straightforward things if you consider here. Now, for this t value, so as I was saying, for a sample size smaller than 25, so what will be the case then? So then it will be a t distribution. Once the sample size is greater than less than 25, so it is considered as t value, right? Once it is 30, it is considered as normal distribution. Once it is less than 25, it will not come into the consideration of central limit theory. So it will be then we will call it as a t value. So this t value will be calculated in this way, like x bar minus mu. divided by sigma under root n. So all these values you know, so you have to just from the table you have to calculate the value, the t value, right? So for one TTS, this one is this degree of freedom. Degree of freedom is basically very close to this number of sample size. Okay, but I mean there's a bit difference. So degree of freedom will be provided. I mean this table will be provided. So these are the confidence levels, or like these are the, you can understand. And sorry, these alpha values are given, so these are these alpha values, okay. And so this is for this 95% case. And so once that is given, you can, from there you can see under which case this is coming, your value or your obtained value is coming, and from there you can calculate the value. So So this was the problem that was provided in the supplementary PPT. You can see here, sample mean of 44.375 is given for a data set of how many? 15 are there, right? So what will be the degree of freedom here? Then it will be n minus 1. As we can see from here, this degree of freedom will be n minus 1, right? So here then degree of freedom will be 15 minus, sorry, then 16 data points are given. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So then the degree of freedom is 15, right? Then what the error bar you can calculate as well. Zero point 0.8, standard deviation 3.199 if you calculate. So, so since this is the sample size is less than 25, this will come under the t distribution. Okay. So the problem is given. So do the data provide sufficient evidence to say that the compound's molecular, so a molecular weight distribution is given. So do the data provide the sufficient evidence that the compound's molecular weight is less than 46.5? Here, sufficient evidence implies that the probability that the statement is wrong is less than zero point 0.1 or 1%. Okay, this is now clear. A similar problem is provided given in the assignment 6, right?
Sir, one doubt. Sir, what is the difference between error bar and the confidence interval?
Uh, physically, I mean, theoretically, I don't know. Like error bar, confidence interval is the limit. I mean, confidence interval. Say you are saying like 95% true, percent true. It is in percentage. But error bar will give you the exact value, right? So confidence interval is just how much percent you are confident. So let's say for 90%, is 90% chance, 100 out of 100, 90 time it will come under the value of within the limit that is provided. But error bar will provide you the actual value, actual limit, from which value to which value it is coming under.
The formula for both calculating confidence interval, the error bar formula and the confidence interval formula look like same, sir.
No, confidence interval formula and error bar formula is not same. So confidence for error bar, this is simply, so this is the error bar, na. Simply this is the error bar. Standard deviation by under root n. So this is counts as error bar, and confidence interval is this one, right? If you look correctly, so this is error bar and this is the confidence interval. I think check once. This is the case. So these are not the same thing, but actually this is indicating towards a similar thing, but the values are not same. Okay. Anyway, so yeah. So as I was saying, so if you look at here, so you see the degree of freedom is 15, and so for 1% confidence, what will be the interval then? It is 2.947. So this is calculated. I mean, you can calculate from here. The t value is coming to be, this mean is calculated. Now t value is coming to be 46.5. So this was the number that is given that we have to consider. Now it is coming 2.66. And from the degree of freedom for 1% confidence, the interval is coming to be 2.947. So since this value is lesser than that, we cannot conclude like whatever this is trying that whether it will come or not, we cannot conclude in that, right? So this is the for knowing this, you need to know that you need to have the table there. Otherwise it will be difficult. Okay. So this was the problem that I think is there. Now we'll come straight to this problem of this assignment 6. Okay, we'll go one by one. I think then it will be easy. So first problem was very simple and straightforward. So data set of 25 is given. Now once 25 is given, so it will come under the central limit theorem, I guess. And from there we can calculate the things. So mean is matched for all, I guess.
Yes, sir.
Yeah. Okay. So
Chandrana, sir,
yeah,
this
yeah,
mean
yeah. You
uh,
can call me Chandra. That is
I
okay.
have written one value only, and the answer was two values. Why it is so? It is two ranges, is it?
Uh,
Because it is because
if you
it
are
is
to
25 samples you are saying. I have calculated
Mhm,
that way only. I've got
mhm.
1.50995 or 96 I have got, and as a mean, so I got only point 0.5 as the answer.
Okay.
Because there is written
What?
type range, is it that we
Yeah,
I should
type
evaluate?
range means it means that so here you can see um, it's down to four decimal places. Okay. Now once it is given down to four decimal places, uh, so that's why they are giving a range. So if your data is coming within this range, then you are correct. Simple as that.
No, I was correct, but I got only point 0.5 as the marks over here because
This
I have
question
mentioned
carries
only
only
one
point
value.
5 marks. This
So
question
this
carries
carries
half
only
marks.
point 0.5, no?
Okay, like that.
Same,
Okay,
same.
okay, fine.
Yeah, yeah.
Okay, okay,
Okay.
okay, fine. Got it. Got it. So,
Mhm.
thank you.
So now second was this error bar. So once you calculate this mean, uh, see, so they could provide only one uh, answer, but the thing is that while calculating, some error can happen always. So that's why they have provided a range. It is always the case, so that
Okay, now I got it because I was understanding why they have provided the
no.
range.
You are, I think, confusing that two answers are there. It cannot be, na. Mean will be only one always.
Yeah,
So
that is
now
what I was.
yeah. Okay. Now go to this error bar. So for that you have to calculate simply the standard deviation and then the under root. I mean divide by that. So it is correct, I guess, for all. Now this is done.
No, sir, my value is coming out to be 0.0109.
09. Yes, sir. I am also
Zero
getting same
one
answer,
zero
sir.
nine.
Yes, sir.
Zero
Yes,
point
sir.
zero one zero nine.
09. Yeah.
0.0109.
Okay.
Same answer I am getting, sir.
Let me then take it as a note. You can write back to this one since you are getting. Just can you wait for a bit? I just get a pen.
Did you get the marks for that when you got 0.0109?
No,
No,
zero
no, no.
marks.
No
Zero
Yeah,
marks.
marks.
0 marks. Yeah, exactly. Same.
But I think it's correct. 0.0109.
Yeah, because I have
As
calculated
per calculation.
using the formulas. Yeah,
Okay, okay. I
simple.
didn't calculate by myself, so I have to check them. But if you feel that your answer is correct, you can write. There's no problem. In the discussion forum or
Okay,
anywhere, you can write that you are getting this because
okay, sir.
uh, now I can see that many people are getting them. So for that, I have to simply calculate. As I didn't do that, but because these questions are said by a course instructor, you understand, right? So this
So,
is the
like these
problem.
problems, if it is manually, it is shown, it is better because people who have used Excel sheet have got correct answers. Who have done manually, we are getting wrong answers.
No, 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 no. I have used Excel sheet only. In that also, I got 0.109 only.
Is it okay?
Yeah, that's why I was.
Okay, okay. So I don't know what to say because the difference is very. So that's why here also you can see they have given a limit, but you're saying it is exceeding actually that. But you can write back. You can write. I mean, few of
Yeah,
you can
okay,
at least
okay, we'll
write. Then
write
that
that.
will be that can be considered. I mean, you can write the actual
Yeah.
problem. So how you are calculating, you can just put a calculation how you are calculating, and make a slide or something. Pen and paper also photograph you can attach, and then I think that will be considered. I think that will be helpful. Otherwise, if you simply say, then I think sir will check. I'll check also. So we'll see.
Okay.
Okay, don't worry about that. If it is correct, you will get the marks. There's no problem. But if it is not, then I hope you are putting the formula is same. It is coming value. The value is coming very close. But yeah, only that the fourth decimal it is changing. It is 9 as you were saying. 0. Point. I've taken a note anyway. 0. 9.
Right.
Okay. So I will check and you can write
If
back
we
as
just calculate in Excel also by putting standard deviation formula, na, it
well.
comes 0.109 only.
Okay, but
Yes, sir.
Yeah,
okay.
So because of
0.10947.
sir, because of that, our next question also get wrong.
Yeah,
Question
I
number
mean
third.
that will be the
Third
case.
and fourth.
Once error is wrong, so your range will be automatically wrong, right?
Yes, sir.
Accepted. And so here it is given define a range in the true value of the concentration must lie with the 95% probability. So for the 95% probability, what will be the case? So for both the values are wrong for you, right?
Yes, sir.
Oh. So what is this coming? X range is how much is coming?
So the exchange is coming 1.49
Uh,
if 4987, but round off to two decimal places, I'm getting 1.50.
Sir, can you show this like how to attempt this question if at all you
Sir,
have?
how can the two values of X range possible?
no, no, it's two,
No,
not
no.
two value,
It
Actually,
right?
is
there
not
is
two.
one value
Yeah,
only,
yeah,
It's
madam.
again.
But they given if the answer is 1.48, it is also correct. And if the answer is
yeah,
1.49,
exactly.
that
That
is
is the
also
case. So it is
correct.
just giving a
That is
limit
also
only.
correct. Only
Huh.
Sir,
one answer is there.
I'm getting 1.4987, but in the
So then you
question
are
round up
correct,
to two
right?
decimal place,
So for
but
two decimal,
So can
1.50
you
is
please show how to do this
Yeah,
problem?
yeah, please. I wanted that.
okay. So this is what is given that range is given for a 95% confidence. Uh, this value, I mean, uh, this value is if in a range in which the true value of the concentration must lie within a 95% probability. Now, so you have calculated the error earlier. You have calculated. You know the mean now. You know the standard error now. Okay. So for calculating this, what is the error we are getting? We are getting. Let's say if we consider what is given here, 0.0169. I mean 0. 01 0.01 0.010 and 08 we can consider here. So the standard error is that now the true value for x will lie within the range. In what range it will lie then for x range and y range basically. So what you have to do that if the mean value you know now. What is the mean value? Mean value is 1.5095. Let's say 1.5095. Uh, Now for this confidence level of 95%, what was the value we have calculated this z value? So formula was
1.96.
1.96.
yeah
1.96.
1.96.
1.96 for
96.
95%, right?
95%
Now
probability. Yeah,
yeah,
yes.
so the simply the thing is that you have to calculate the value will be in the range of your mean value minus
1.96.
this z into your standard error. So because you can see if you go to the formula, this is the case. X bar your mean plus minus Z value into error. So X mean we now know. Now for this 95% confidence level, Z value we know. We have calculated the error also. So what will be the value then? That we have to calculate simply. So if you put all this value, what will be the case? Let me, this can be doable. Now you also calculate what is coming. That will be easy. So mean you we are taking as 1.5095, 1.5095 plus and minus. So any weather range. So first you do the plus 1.96 96 into what is the standard error value? 0.0108, 0.0108. So then what will it come? 1.53 something like that is coming. So class value is coming 1.530068 and the negative one. It is coming to be as 1.48. Okay, so anybody is calculating? I hope you'll get the answer. So for my case, I have put the formula and it is matching to this range x and y.
It is coming 1.476.
So what are you taking? Which value you are taking? It depends. So
Yeah.
as I said, the value, let's say now, so whatever value you have gotten here, that is okay. For now, you can take the value that is provided. So you can take this mean value as 1.5095, this one, and
Yes, yes, I have taken that.
error we are taking as this one, 0.0108, right? So now you calculate. The formula you understood, right?
Okay. Okay. Yeah, yeah.
Okay. So others, one will be with plus and other is with minus. So simple as
Go
that.
to the previous slide. Okay.
Excuse me, sir.
Yeah.
Sir, means when we want to calculate range, in that case only Z score is multiplied with standard error.
Can you repeat? I didn't understand.
If we want to calculate range,
Uh-huh.
in that case only Z score is multiplied with standard error. Otherwise, there is no need to multiply standard error in a mean with
Yes, yes.
Z
So,
score.
so for confidence interval calculation, that is the formula, na?
Okay, okay.
Yes, yes.
Now it is correct. It is coming 1.488.
Yeah, one will be 1.48 once you
Yes, correct.
minus it, and once you add it or plus, the plus range is 1.53.
So Y range, how do you calculate? This is X range we
No,
have
this is plus
calculated, right?
minus, na. This is plus and minus.
Uh,
So once you do plus,
okay.
this value is coming like this. Once you do minus, this
Okay.
value is coming like this.
Yeah, yeah,
So,
got it, got it, got
yeah,
it.
I
Got
Y
it,
hope
got
is
it
it.
is
the
matching.
higher range and X is the minimum range,
Yes,
lower
Yeah,
range.
yeah,
minimum
yeah,
and
got it.
maximum range.
Upper
So I think this is matching for
critical
all,
limit,
right?
lower.
There's no, should not be.
UCL, LCL, what you call
Yeah.
it.
So can I move forward? Okay, then I think I can. I'm moving to the next question because it will be difficult to finish. Okay. So the next question was, with what confidence level can you state that the actual value lies in the range of 1.5 ppm to 1.519 ppm? So this is the same, na? So there in the earlier case, what was given? The 90 confidence level was given. Now you have to, the two range is given and you have to calculate the confidence level. So you can calculate then. Is it okay for all?
No,
In the
sir.
same way.
No, no,
No, sir.
he
No,
No.
sir.
can help
Please
to
explain
explain us.
that.
Yeah. So the, the problem is not about that. So in the earlier case, what was given? Like, yeah, 95% probability is given, and you have to calculate the value, uh, whether the value is true or not. Now here, if you see, you have to calculate the confidence level, right? So so with the confidence level lie in one. So just a minute. So the data set is basically same, right? Now you know the so the upper limit and lower limit is now given as 1.5 and 1.5192. What is the confidence level? So can you state the actual value? So if you put the formula simply, the formula is same, na? So the formula is same. This one is the formula. So now here what is given? Uh, let me copy paste it. It will be easier. So here the upper limit, and so one value, one point. This is the upper value, and this is the lower value that is
What
given.
confidence?
Okay. Now you know the mean value. You know the error. You have to calculate the z. Once you calculate the z, from there you can easily get the confidence level. How much percentage? You just try.
Mm,
This is the continuation of the same question, na? So every value you know. In the earlier case, this one you have to calculate. I mean, every value was given. You had to calculate this one, and now you have to calculate the interval value. So once you get the z value, from there you can easily calculate what is the percentage confidence level.
Excuse me, sir.
Yeah.
Sir, again to calculate confidence level, there is need of n. It may be number
Yes.
of samples or population. So,
Yes.
what we will take there to solve
So
that problem, sir?
what is the sample size? Sample
25
size is
sample.
given. 25 is given.
25.
Okay, 25. And how to calculate Z, sir? Actually,
Yeah, z you have to calculate, na. Other values are given.
Z.
See, so you take one value, then other values are given. So z you have to calculate. Then you have to see in which range it is coming. So then only you will be able to.
So here, so confidence interval, sir, what he, because they are asking the value lies between 1.5 to 1.5192.
Mhm.
So do we have
So
to
the
take the, because
maximum.
here
So
we are
so the maximum is so you see here you got a maximum value and a minimum value, right? That you
yeah, yeah,
got.
yeah.
Now they have
Yes,
provided these
yes.
two value and they have asked for the opposite one. So and they have asked for how much percentage you are getting, or percentage probability that they have asked.
Okay. So we have to calculate for both, is it? Here also.
Just a minute.
So just a request, if this steps are, is given,
Yeah,
it will
yeah.
be easy, because the previous some one part I got it as, sorry, I'm going back to the previous one,
Mhm.
0.81, but the other value I'm getting 3. If you add 1.5095 plus Z value and 1.016, it is coming to 3. How it is, I don't know. But other minus, it's coming as 0.481. So if you manually, like, if those
Yeah,
steps are
yeah. I'm
shown, so
showing.
it will be
I'm
better.
showing. Yeah, yeah, yeah. Okay, okay. Just a minute. Yeah. So okay. So then the only option is to do manually. So you see, so x, what is the x? What is the mean value?
One
Mean
point
value, yeah,
one
one
point
point
five zero
five
nine
zero
five.
nine five.
Yeah.
Sir, here we need not to be calculate the confidence interval. The value of z itself tells the confidence level.
So yeah,
No, no, no. This based on this value, we should know what will be the confidence interval.
yeah. So
Which
that is their
within
Here
confidence.
they
which
have
one standard or two standard, three standard, where does this value fall? That is what we have to find out.
Yeah,
The formula for calculating z score is the difference between the sample means and the population mean. So the sample mean, the accurate value, the we already know it from the above answer, and the given range is 1.5 to 1.59 5192. So
5192.
we have
Yeah,
to put those values in the formula of calculating z score. From there, we
yeah,
need
that's
not to
what.
be calculate the confidence
so
interval.
so can you show? I'm not. I'm get you. So can you just repeat, or if people are getting? I
Okay.
think. Yeah, yeah. You just tell. If you wish, you can show also. There's no problem. Hello.
Yes, sir.
Yeah, yeah. So you just repeat. I think people are listening, so you can repeat.
Sir, the formula for calculating the z score
Hmm.
is difference between the sample means to that of the population mean divided by the standard error. So here we need to calculate the
Yeah,
value of standard error. We have already know it's coming out to be 0.109.
yeah. 0.10. You got it. 0.010.
109. Okay. So the numerator part is a difference between the mean values, between the sample mean to that of the range, the given range. So we have to put the given range
Yeah, given
two
range
times
is 1.5.
1.5. Yes,
Mhm.
sir. So first the value of z score scale, when we put the value 1.5, the 1.5096, the actual true value of mean, we have already calculated 1.5096 minus 1.5 divided by
1.5.
divided by 0.0109.
Okay. And how does that come?
The value of standard error, sir. The
No, no,
denominator
no.
part
I'm
is
saying that what is the? I mean, so you are saying that we know this mean now. So you are taking in this value as 1.050
5096, the sample
five
mean, right?
sample mean, yeah,
Yes,
5095, or we are taking 5095, let's say, and the
yes.
error is
Error is,
0.0108.
yes,
Yeah,
sir.
okay, now.
So when we calculate the value of Z
Uh-huh.
for the given range 1.5,
Yes, you
it's
have
coming
to.
out to be 0.8807.
Okay, you are simply subtracting, right?
No,
Yes,
if you no, it comes up to, if we say like 1.5095 minus 1.5, it is 0.0095. Done. So
One point.
0.0095 divided by 1.16 is 0093. 0.0093. If anyone cross checks, it's coming at 0.0093.
Okay, so
the numerator part is coming out to be
let me write here.
0.0093.
So you tell me the values. One point. So mean
No.
value is 1.5095. Let's say five
Yes, sir.
zero nine
Minus
five
1.5
minus 1.5. This is the upper limit. Okay. So
divided by the standard error
yeah. So this value.
0.010.
Yeah.
Uh,
So this will be,
So it's
yeah,
0.0095. Answer is,
divided by
yeah.
divided by, yeah,
0.01019.
4 or 6, whatever.
0.01, zero,
09.
whatever, 08, let's say. So yeah. So
Okay, sir.
how much is coming then?
0.88.
Okay, this is not even close to the answer given. Let me check.
So this is the one part of the left hand side of right hand side of the NPC curve.
Yes, yes, yes.
And
Understand.
while calculating the right hand side of the NPC curve, we have to take the range given range value again
Five
1.5192
one nine two.
and
Yes, yes.
subtract it from again the mean actual true value,
So
divide by the
basically,
standard.
the value will come here only, 1.509. So then that will be the
Hello,
mod value. Mod value means only the
hello,
value.
sir.
Yeah.
Yes,
Hello,
sir.
Yes, yes.
hello, sir. Can you hear me?
Yes, I can. I can.
Sir, I do the calculation. I share my slide for some time.
Yeah, yeah, sure. Sure, sure. Let me, if you wish, you can.
Think we, with the value, we have to go to the Z table and then we will get, I guess. No?
Yes, yes, yes. So uh,
Yes, sir.
I'm stopping them for a few minutes.
Once you calculate the Z value, then you have to refer the table, the
Yeah.
given Z table.
Now I'm getting it. Thank you so much. Thank you.
So I think this table. I think in the solution section, I mean, this table is provided. That's why, right?
Can you see my
Okay.
screen?
Yeah. Can you full screen, go to full screen mode? Yeah. You just download that. I think that'll be better. Otherwise,
Okay, okay, okay.
uh, you open. Yeah. Now you go to the full screen mode. Go to the slide share mode.
You can see.
Yeah. Yeah. Now
Yeah,
it's
we
clear.
can see.
Okay. Yeah. Yeah. Okay. Tell us.
Sir, actually, in the calculation, we do the error that we made the mistake that this part is the mean is 1.5096. Then we can calculate this xi minus x bar. We got this result, and then we, after squaring this part, we get 0.0675 36256. This is the xi minus x bar, and this is HD come 0.05 300630. 47, and the error bar come is 0.0106,
Okay, that is okay now.
and range is coming 1.488
That
and
is, yeah, yeah.
1.503.
This is also okay. Now come to the last part.
According
Question number
according
five.
to jet table, the curve is coming like that way: x minus mu by sigma, and
Yes.
another side x minus mu by sigma in the right hand side and the left hand side. Uh, in the, here this that range is 1.5 to 1.5192. Then we can calculate that 1.5 minus mean x minus mu, that
That
x is
is,
given 1.5 and mean is 1.5096, and standard error means uh, AC is given the standard error means SD by sigma. Here sigma is as per the SAD notes, the S is unbiased estimator for sigma. So we use this standard error as
yeah.
sigma value. So
So
the value is coming 0.09088 something value. So I
yeah,
approx
okay.
this value, and this value is got this, and from the jet table we get the I get this value that
Yeah.
0.9 value is coming 0.01859 minus 1, and this
Yeah.
is 0.6318, and confidence level is 63%.
Yes, yes. That's what, like, that's what
No, please
you are saying.
explain the last part of it. Please, can you explain the last part?
Okay.
This part,
No, no.
Last step,
Last
how you
part
got the
means,
63%
yeah.
confidence level? How do you get it? That last step. Z
last step,
plus,
uh, the jet value is lies between minus zero point 0.9 to 0.9. In the
okay.
jet curve you can find that minus zero point 0.9, this is integration from 1 to, total integration is 1, and you can calculate this, you can manipulate this minus zero point 0.1 as 1 minus 0.09 in the jet table. You can find minus 0.09 value from the table, but for simplicity you can this step 0.1 minus zero point 0.9. I take this, then 2 into 0.09 minus 1. You can see the sand notes.
Yes, yes, yeah.
Yes,
Yes, yes. This is,
sir simply divided the two curve region and into 2 minus zero point 0.5. I just opposite that. I just I just take total value as 1, and then minus it. Then minus it for integrate the zero point 0.9 part.
What is the 2 into 0.8159?
2 into
2
point
into,
0.8, the jet table provided, in the jet table the value is zero point 0.9 value is coming 0.8159.
8159.
why did you multiply it to 2?
Why did multiply into 2? You can step 1 2 3, you can directly step third step, you can directly uh, calculate the answer from the third step. You can ignore the this calculation. You can directly calculate from this third step. Here
Okay,
first you can see the value zero point 0.9,
mm,
and another jet table minus jet
okay,
table. You can get
okay,
the value minus zero point 0.9. You can
okay,
same this value.
okay,
Same
okay.
get
The X
value
and
this
Y
value.
axis will coincide at
yeah.
63.1. Okay,
Yes,
I
yes,
got,
yes,
okay,
yes.
okay, okay. Thank you so much. God bless. Thank you.
Okay. So I think this is clear for all.
Yes, yes.
Yes, yes. So basically, you have to correlate the values whatever you are getting from this formula to the jet table, and then you can find the answer. So
Can you share once with
Yes, I'm sharing.
Saroj? Yeah,
Okay, so
that calculation what
okay. Saroj,
Saroj
can
has
you please share again? So,
just share for a minute. I'll
or
take
you can take a screenshot and
screenshot.
share.
Yeah, I was
Yeah,
trying to
and share
take
with
that,
all. Now
but he
this
is
is,
removed.
yeah. You can put that in the chat box, or you can share also.
So I still have doubt with the previous question. Plus is coming 3, minus is coming 0.481. So anybody can clarify?
Which one? Plus is coming 3 and minus is coming 0.84. I don't know. So people was done the calculation. Can you clarify, please, Saroj?
I think she's not there.
Are you there, Saroj? She's not there. Okay, but what I think is that the calculation that was showing that is more or less correct, right? So others are getting same or not, that you just confirm, then we can, but then we can check. Or so answer is actually matching, but she showed that the value that is coming, that is matching with the z value, z table. But then you have to cross check, I think. But if many of you are facing problem, then I can check. So anyway, I have to check in, like, so I am sharing them.
So like 1.96 into, that is Z value, into 1.016 or whatever. It is coming up to 1.9913. 1.9913 plus 1.5095 is 3. So how, but if you're minus, it is coming to 0.481. So minus I'm getting correct. One of the values is wrong. So if
No,
anybody
that
can
both
clarify.
are coming. 1.53 it is coming when you take the upper value. 1.53, right?
So yeah. So
Lower
can
is
you show? Can you
See,
1,
show?
1.96,
sorry.
1.96 into 1.16 is equal to 1.9913. Done.
So which you're talking about this problem only, right? Or
Yes, sir.
okay. So
No, sir,
can
no, so the
anyone
previous
clarify?
one. Not
Previous
this one,
one,
the
yeah,
previous
that's
one.
yes, yes.
X and Y value.
Yeah.
One value I'm getting it correct, one value I'm getting it wrong.
Which one you are getting correct?
So
1.48,
I'm getting this 4.81 I'm getting, 0.481 I'm getting correctly.
1.48. I didn't know. 1.48 is there.
One sec.
1.48.
Sorry. Okay.
That is 1.48 and another answer is 1.53. That is correct only. I think you
Yes, sir.
might be taking the values wrong. That is
Yeah, must be some.
1.5095.
See how you have done it, 1.5095 plus or
Yeah.
minus 1.96 into
Error value.
Plus or minus
0.
1.96 into 0.0108.
zero
Yes.
point. Okay.
Sir, can you explain this the question,
Done.
sir?
No, no, I put a wrong value. Sorry, I put a wrong value. Yeah.
Okay,
Now
that's
I
not.
got it. Yeah. Yeah, my value was wrong.
Sir, please explain the fifth question.
Okay.
Sorry.
Fifth question that we are discussing, na? Can you please
Yeah. So
explain that thing, sir?
this one, na?
Fifth one, yeah,
So
which
actually,
we
I
were
put a wrong value.
discussing.
I put
So
1.01. It is 0.01. That's why. That I.
It's 0.0108.
Yeah. I put one. It's my mistake. Sorry.
No problem.
so for this case, you have to simply put the formula of this confidence level. So confidence level formula is this one.
Yes, sir. Now
So
it's making sense. Yeah.
yeah.
Thank you.
So you have to provide the mean value we know. Z value for 95% confidence level we know 1.96 that is, and error value we know. So now you just put one case plus and other case minus. In so you will get
To calculate y, we have take minus, and to calculate x, we have take plus.
yeah. Simply put this formula here, and you will get the answer. One is with this either 1.48 or 1.5. So these are the two options answers for a range. So that I hope this is correct for everyone.
Yeah, that is done. Yeah. Can
Okay.
we move ahead?
So here one problem was given. A scientist could take only 10 measurement on a molecular weight of a new compound, and the measured values were this. What is the standard error in mean? It's also easy, right? 10 measurement means it will automatically come under this t-test. So from there you have to calculate.
Sir, in this question, excuse me, sir.
Please.
Sir, in this question, I got the answer 0.86
Same for me also. I got 0.86.
as per calculation, sir.
So you have given the t-test, right? You have done the t-test, not
Yes, sir.
0.86 you are getting for question number 6. I don't know, I have to calculate actually that then only because it would be better if I could show you the calculation. I think I'll request you to recheck once again with the same values. You might have made a mistake, or I don't know.
No, sir. Number of times we have checked that, but still I am getting 0.86.
Okay, okay. So then you can write back, right? You can try, simply say that since you are getting, so you can write back with the proper how you have done, right? There once you can write to sir, then I think that will be considered. If that is correct at all, then that will be considered. Because the formula is very straightforward here. Nothing we can do with that. So once you put that, I hope it should come same. But so what is the case for others? Is it coming correct or it's not
So it
matching?
is
0.86.
wrong.
I got 0.86.
Okay, okay. I'll take a note. Then I'm taking, and I'll I will check it with sir. What is the answer? And we can write as well. We'll see. So now, but the formula is clear to you, right? The answer is, I mean, it might be some calculation mistake, but if you are clear with the formula, that is the main thing. So
This is
here,
only,
sorry.
sir, in this standard error of the standard error in the means the same standard error formula we'll use, no, after calculating the mean.
So what should it be? Should it be
Yeah.
different or same
Yeah,
for
yeah. Because when
calculating?
they say standard error in the mean, it is the same standard error formula, or how's it like in the
No,
mean
that's
when
what
we
I'm
say?
saying. So for calculating standard error, so there is a role of t-test or something like that or not. So if you see, so in that formula, if you see, so there is a role of sample size or not.
Only 10 measurements are there.
10
So
measurements, so that is less than 25. So now, how to
mm,
calculate this
then
error?
t-test has to be used.
Okay, if that yeah, so then if that is the case, then it should come like that only. It should not differ.
Hmm.
Yeah.
Okay.
Okay. So I
Hello,
think yeah,
hello, sir. Sir,
yeah, yeah,
I
Just
want to.
Thetis formula. Can you just put it once, please?
yeah. It is provided in provided for the t-test. One problem it is. So this is the formula actually for t value 6 bar minus mu under root by sigma upon root n. So this is the formula. that you can get.
Sir, hello.
Yeah, yeah,
It's the
yeah.
same, no, sir?
Sir, I
So that's
want
what I'm
to.
saying. Na? So it shouldn't change for this calculating error. It shouldn't change then, right? Error should not be changed, right? Sorry. So
Hello, sir.
anyway, yeah, please tell.
Yeah, tell.
Hello, sir. I am Abhishek. I want to say that uh, in the question number 6, when we take the sample 10, then the standard error come 0.82. If the sample
So
size 9, take then 0.86. Then which formula we can use to find this standard error? Sorry, to find the standard deviation.
so how are you calculating the standard error? Can you tell us?
Uh, just like a formula that xi minus x bar. Previous slide I will share with you na, where we calculate the mean and
No, no. Can
calculate
you say the can you say the formula? What is the formula?
yes, uh, 1 by n
You can.
sigma xi
I
minus.
think Abhishek, it will be better if you share once to all. Since people are
No,
confused.
same thing. Summation x minus x bar the whole square by n. That is what she's telling. Square root. Same
Okay.
formula she has used. What she's
Okay.
telling is, should it be n minus 1 or should be n? So those who have used n minus 1 are getting a different value. Those who are using n are getting a different value. What should you use?
Yes, yes,
Is
yes,
it
yes.
square root of n minus 1 or is it square root of n? That
It
is the
should be
question,
square root
sir.
of n by n minus one. Like in the error formula, if you see, it is under root n only, not n minus one. So if it
Is
is
correct,
that,
No,
sir.
no, no,
For
no.
error, madam, for error there is under root of n, and for
yeah,
standard deviation there is
n
under root
minus
of
n
n
minus one.
minus 1.
Yeah.
I have
So
taken
that is
same, sir.
yeah. So then it should. So if using 10 it is coming 0.82, then it's correct, I guess. If someone is getting that value, right?
To calculate error, you have to use their under root of n in the denominator.
Yeah, yeah. So that's what I'm saying. Like, since it is n error, so for error the formula is under root n, not n minus one. N minus one is for this standard deviation. So that's what I'm saying. So if you are getting that, so I mean, some people at least are getting the value is correct. Though, then I think it is correct, right? So
Okay.
okay. So anyway, we'll discuss the other things. I mean, we're almost finishing. So the other parts, I don't know if you join.
Sir, can you discuss the
7.
next question, sir? 7.
Yeah, 7.
Yeah, I think I will discuss this in the next. So because few are still remaining, so we'll discuss in the next session. So I have to anyway discuss. There's no problem. Uh,
And few
Sabya's
more
can discuss.
calculations, sir. Next class, few more
Yes, sir.
calculations for this. Huh?
Yeah, few
So
more
that we will have in
95%,
Saroj is
detail.
like,
there.
problems,
yeah.
right?
Yes, sir.
Sir,
This
tell
how to
Saroj to
calculate
put that
65,
question.
63 or 95 confidence
Okay,
level.
okay, okay.
Those
There
things,
are
the
multiple
quick, small,
problems that.
small sums, no easy sums. So we'll get it like.
Okay,
Let it
okay.
not be point 441.8 and all, like
But the problem
numbers
is
which
that
is
this
easy,
this kind
easy
of
numbers.
problems can be
Saroj is
provided
there. Can she put that?
in the exam. So that is the case. It's better to be accustomed to this kind of numbers. So that then it will be easier for you. Okay. Anyway, I mean,
Okay, okay,
how
okay,
to
sir.
do
Done.
the
Sir,
at least put the formula. Yeah, yeah. Please tell.
sir, I can share my screen to see this
Yes.
solution of question number 6.
I think people have
Yes,
gotten
yes.
it already. People have gotten it. So you have to take the under root 10, not 9. So that's why you are confusing now. So standard error formula is
No,
under
no,
root n.
I want to see the I want to say that in this standard deviation formula, there is a two formula, na? Uh, one is sample size is there is 1 by 10 into I will share I will
Okay,
share
okay.
and
If you can. Okay.
You can put in the WhatsApp group also.
Yeah.
Is there WhatsApp group of ma'am?
Yeah, there's a WhatsApp group, no? The link was sent.
No, but I don't have that. Can you share that link, Regina?
this
I have
formula
also not joined.
you can see
Is
my
it?
screen.
So
Yeah,
somebody
yeah.
sent it,
Yes.
like, I think, yeah. I think sir will be better to get you the link.
You
No,
can see my
I
screen,
don't. I am also not in the group, so if anyone is better.
Okay.
Yeah,
Yeah.
Regina, can you add me? Add me in that group.
sir.
How do I do it?
Yeah, yeah. We can
I'm
Hello,
not
sir.
see.
sure.
Abhishek. Yeah, Abhishek, we
Sir,
can see. We can see your screen.
sir, in that case, I take 1 by 9 and got this 0.86. When I am take this 10, 1 by 9 is 1 by 10, then I got 0.82.
You have
Okay.
done correct. This is correct.
Yeah. Yeah, this is correct, na?
This is
No,
correct.
this is not correct actually because the value is showing that 0.86 should be 0.
0.86. Sir, actually maximum people are getting that value, sir. 0.86.
Yeah, that's what I'm saying. So then you can write to sir. Okay, this was the confusion. So okay, I was
Yes,
thinking
yes,
that
yes.
This is
you are
actually
confusing
confusion,
with
sir.
this. Okay, okay,
No,
okay.
you thought it was standard error. No, no, it was not standard error. It's standard deviation.
Yeah, I thought of standard error. No, standard deviation. This
No, no.
formula is correct. So you can write it to sir. I think it's okay, no problem.
Sir, can you
Okay.
please convey this message to sir?
Yeah, yeah, I'll convey to the other TAs as well that people are confusing with this value. So if I am making some mistake or I'm making something wrong, they can so that they can correct also. Can be that I am
So that we will
doing
get
something.
marks on that, sir.
Sir, Feroz,
Sir, where are
share that
the PPTs shared?
Sorry.
So where are the PPTs shared? The PPTs you're
So
showing
there
us,
is
where?
there is there is an Excel sheet, na, that is shared in the. I think that is there.
Yeah, it is there in
It is
the
there.
module only at the
Those
bottom.
module you
So
go
you
so
can go and put other videos
Sir
and
shared
there
videos
was
and
Excel sheet.
PDF.
problem
PDF,
solving
everything
session.
is there.
So if you go there, so there it is.
Okay.
Yeah, you just go to this link, so it is shared. So all right, everyone. Then today I'm closing the session. So next, anyway, there are
Thank you so
sessions
much.
tomorrow and Tuesday. You just attend those, and yeah, you can write as well with the problems, and we'll resume with the other problems of week 6 and the 7 as well. Okay. Okay then. Bye bye.
Thank you.
Yeah.
Thank
Okay,
you,
thank
sir.
you, sir.
Yeah. Thank you. Thank you all.